I'm buying.
Yes, it is the 25th. That was one
Super
Tuesday,
Tuesday.
Tuesday, the 25th of February. SBA, what's that stand for, Matthew?
Digital bill.
Awesome. Factor by using the distributive property. Factor by using the distributive property. We're going to learn what factoring is. Okay, it's a pretty neat thing. Okay, I think it's pretty neat. You might not, but I do. Okay, so
All right, let's get this going.
let's write our name on here.
Oh my
Oh.
god.
What in the world?
That was awkward. I wasn't even the last person to use the door.
The door.
Board.
What in the world?
Ah.
You all okay?
No. Don't assume that I'm okay. That's illegal. Sadly.
All right.
What?
So let's first write our name, Mr. Castle, right? Oh no, we're first saying Mr.
That's a breakdown.
So.
Mr. Sir.
No.
Yes, totally not. Okay, so factors. Factors are numbers and or variables that divide evenly into a term. Factors are numbers and or variables that divide evenly into a term. We've also talked about factors before as two things that multiply to get something, right?
Yes.
We said, what are the factors of like 8? And you guys might say what? 2 and 4, and
4 and 1.
8 and 1. Yeah, you might say those are factors of 8, right? 2 and 4, and 8 and 1. Okay.
2, 4.
So what are the factors of 72? Raise your hand if you tell me some of the factors of 72. Matthew. Okay, 9 and 8. What am I actually going to do? 8 times 9. Okay, so 8 times 9 is a factor. What's another factor?
9 times 8.
Okay, we already said that.
Why are you writing so low?
Okay.
72 times 1.
Okay, 72 times 1. We'll see why in a moment.
So am I supposed to do that?
If you want. Yeah. Okay, what's another set of factors?
No.
What's half 72?
34.
36. 2 times 36. What is 72? 2 and 36.
Woo.
There's 3 more pairs. There's 3 more pairs.
30. There's 30.
There's 3 more pairs.
3 times 13.
3 times not 13, but 3 times
12.
Did you say 24? Yeah, 24. Haha. Okay. There's 2 more pairs. Okay. 6 times 12. So hold on 6. Very good. Now there's 1 more pair. Notice where I place it. So it's between. We notice between what 2 numbers?
In between 3 and 6.
4 times not 17.
18.
18. 4 times 18.
Close
Okay.
enough to like.
So that's why I put it in that order, Nicaria. It was just so it's like it goes numerical.
Oh,
1, 2,
okay.
3, 4, 6,
What
8.
does it say? Close enough only counts for horseshoes and hand grenades.
Yeah. Yep. And then I like to add in that it also counts in nuclear warfare. But anyway, so these are the factors of 72. Okay? And I just listed it in order so that way we could make sure we got them all. Okay? I like to go from lowest to the greatest. Say, okay, 172, 2 in this, 3 in this, 4 in this, 5 doesn't go into it, so on and so forth. So those are all the factors of 72, right? Now we have a prime number. A prime number is a whole number greater than 1 whose only factors are 1 and itself.
3.
A prime number is a number greater than 1 whose only factors are 1 and itself. Then we have things called composite numbers. Composite numbers is a number that is not prime. It's not prime, it's composite.
That is not Optimus Prime.
It is not Optimus Prime. Okay? So, a little note, 0 and 1 are neither prime nor composite. They're neither. Okay, so they're not prime or composite. They're considered to be neither of them. Okay? Just by your definitions of prime and composite, 0 and 1 are just excluded.
But 1 is not a prime number.
Correct.
Technically.
In this case, these are left out.
Wow.
Yep.
This is the bullying numberist. This
Yes.
is numberist. That is
Totally.
bullying.
So we have our prime and composite numbers. The prime and composite is something new to us, right? You know what prime numbers are? Talk about that. Okay. What are some examples of prime numbers? What are some examples of prime numbers? Okay, 2.
4.
Okay, nope. 4 goes into 4.
2 and 2.
2 and 2. 3 is a prime number. It's another prime number.
4.
Nope. 5 is 2 and 2 go into 4, so it's not prime.
Yeah, we finished with 6.
Okay, 7 is a prime number. What goes into 6?
3.
3 and 2, so it's not prime. What's another prime number? What goes into 9? 3 and 3. 11 is prime.
85.
Okay. 85. Nope. Go 5 goes into it.
13.
Okay. 13 is prime. We can keep going literally forever. Actually, there's actually a math theoretical math proof that states that there's an infinite amount of prime numbers.
What bet?
But-
Let's bet a lot.
No,
We got
I
all
don't want
day.
to bet because I won. All right, I'll bet sure. Unless it must read on Apple Street. Sure, I'll bet. I'm right.
We got all day.
Okay.
We got all day. We can ride them all out.
Okay. Yeah. Well, there's an infinite amount, so literally it would take forever.
We got
That's what infinite would mean.
Yeah,
is
we
that
got
it would
forever.
take forever to do it. Okay. So let's
I'm
continue on.
I will live forever.
So here are some rules for divisors to see if a number goes into it. Okay, so it'll be helpful in this chapter, especially guys, if we see if numbers go into another number. If a number is a factor of it or divides it. Okay, so here's some helpful tips for some numbers of 2 through 10. Not all of them, but 2. If it's an even number, so if it ends in 0, 2, 4, 6, or 8, it's going 2 goes into it. Yeah, it can be helpful to know. 3. A lot of people don't know this one, but it's really helpful. If the sum of digits is divisible by 3. If the sum of digits is divisible by 3, then 3 goes into it. So, give me a number, Nectaria. Give me any 3-digit number. 20.
3-digit number?
Sure.
367.
Okay, so Nectaria said 367.
I was gonna say 66, but then I was like, I don't like 2 sixes.
Okay,
What about
so
360?
367. Now, I can tell you right now this is not divisible by 3. And it's not because I just know all the multiples of 3. But if I add up the digits, 3 plus 6 is 9 plus 7 is 16 divisible by 3?
No,
No,
sir.
so that means this number is not divisible by 3.
What about
Okay.
666?
Okay, yes it would because 6 plus 6 plus 6 is 18,
Aha.
which is divisible by 3, okay?
Smart.
Presley, give me another 3-digit number.
249.
Okay, 249, what's 2 plus 4?
6.
What's 6 plus 9?
15.
15, is 15 divisible by 3?
Yes.
5 times.
So 249 is divisible by 3.
You add that up just so you can say
So,
that. Well, that
that's
was
how we can know instantly if a number is divisible by 3. It's a really handy trick, okay? It's a really handy trick.
like the
Okay,
night.
I use it all the time. Okay. 4. To know if it's divisible by 4, if a number is triple digits or more, then you can know if the last 2 digits are divisible by 4. It's divisible by 4.
What if
For
you-
example, if you have like 1,804, are the last 2 digits divisible by 4? Yeah. So this whole number is divisible by 4.
What if you do like 1,222?
Okay, is 22 divisible by 4? Try again. No,
What about-
so then it's not.
What about 2,820?
Because the last 2 digits, 20, is divisible by 4. Okay. 5, the last digits here is 0, 5. Okay. 6 is if it's divisible by both 2 and 3, you can divide it by 6. If you can divide it by both 2 and 3, you can divide it by 6.
So like 18.
Yep. Yeah, 18 is divisible by 6 because it's divisible by both 2 and 3. Okay. 24 is divisible by both 2 and 3, so it's divisible by 6.
Like 1,475,000.
Maybe.
18.
So, 8, we won't use this one much because it's the last 3 digits are divisible by 8. We're not going to probably memorize that. Okay. 9, the sum of digits is divisible by 9. So it's the same as the 3 trick, but it has to be divisible by 9. So here, what's 2 plus 4? We said earlier, what's 2 plus 4? 6. What's 6 plus 9? Is 15 divisible by 3? No. Or excuse me, is 15 divisible by 9? That's the wrong question.
No.
No, so this number is not divisible by 9. Okay, but if you give me another number, let's say we do 549. What's 5 plus 4?
9.
9. What's 9 plus 9?
18.
18. Is 18 divisible by 9?
Yes.
Yeah, so this number is divisible by 9. Okay, and 10 is just that ends in 0.
Why did I think that might end in O? But I realized that does not make sense. Because this is 9.
It's true, it's true. Now, have you guys heard of
Good
the
job.
term greatest common factor,
Uh-huh.
or GCF?
No.
Okay, we're gonna use that a lot. Okay, we're gonna use it a lot. So this whole chapter is based on factoring. This whole chapter is based on factoring. Okay, and factoring is basically the reverse of what we just did. So we, you know, guys, we just went through and did a bunch of multiplication.
We're doing a lot of
Distributing.
division.
Okay, we're doing the opposite of that. We're factoring out. So instead of putting things into parentheses, we're taking things out of parentheses. Okay,
It's
instead
gonna be a
putting
lot of
things in,
writing.
we're gonna be taking things out. We're gonna do the reverse process here. So the greatest common factor, or GCF, okay, of two or more integers is the greatest number that is a factor of all the integers. So it's the greatest number that goes into both. So common factor, a factor they both have. In this case, we're just looking for the greatest such one. Okay. So for example, 8 and 16. Now, what are the factors of 8?
4.
Okay. 2 and 4, and what else? 1 and 8, or 8 and 1. Okay, what are the factors of 16?
2 and 8.
Okay, 2 and 8,
And 1 and 16.
1 and 16, and 4 and 4.
Yes.
Now these have a lot of common factors, right? They both have 1, 2, 4, and 8. But which one of those is the greatest common factor? 8. 8 is the greatest common factor. Okay? Because 8 is the biggest number, greatest number, that they both have in common. Okay? These are 1, 2, 4, and 8 are all common factors, but 8 is the greatest one because it's the biggest. Does that make sense?
Mhm.
Okay, so Randy's telling me a big no, okay? Does it make sense why 1 is a common factor of both? Okay, does it make sense that 2 is a common factor? 4?
Oh, I see what you mean now.
Okay.
Never mind.
Okay, are you just saying that or do you actually get it?
I get it.
Okay, dope. Okay, thank
Thank
you for letting me know.
you.
So let's go back and recap, not no cap, but recap the distributive property. We did this in our warm today, didn't we?
You're
Okay.
funny.
Thank you. Okay. So we do 3 times 2a and 3 times 4. What's 3 times 2a?
Are you sure you're not straight
And what's 3 times 4? 12. We just go in and we distribute, multiply them through. Okay. We can do the same thing here. 2x times 4x is
8x squared.
8x squared. Very good. 2x times 5 is 10x.
Yes.
So now we're going to use the distributive property in reverse to factor each polynomial. So we're going to start with where this might be 8x squared plus 10x. We're going to start here, and we're going to end with the parentheses. So we're going to start at the end and go to the beginning compared to last time. So what you have to do is you have to find the GCF, that greatest common factor of all the terms, and then we're going to what we call factor it out. Okay, and we'll see what this process looks like. So if we're asked to factor this polynomial 15x plus 9, okay, well, what's the greatest common factor of 15 and 9, these two terms, 15x and 9? What's the greatest common factor of 15 and 9?
3.
3 goes into both, right? So what I'm going to do is I say, okay, my GCF is going to be 3 here. So I'm going to say my GCF is 3. Now, if I were to take that GCF, I'm going to put it outside the parenthesis. So I'm going to make a parenthesis here, and I'm going to put that 3, the GCF, outside.
Yep.
Now to figure out what goes inside the parenthesis, is I'm going to take each of these terms, and I'm going to divide it by our GCF. So what is 15x divided by 3? 5x.
X.
The plus sign stays plus. What is 9 divided by 3?
3.
3. So I end up with 3 times the quantity of 5x plus 3. Now notice, like I said, did we end up ending with what we would start with in our previous problems? Yeah. And if we went back through, guys, we went back through to check this, we could distribute it, and we should get exactly what we started with. So if we distribute it, what's 3 times 5x? 15x. What's 3 times 3? 9. So did we end it with exactly what we started with then? Yeah. So if you can go back through and redistribute, okay, you're going to have your answer. So this is what we call factoring. This is what we call factoring, and we'll actually have it come in handy quite a bit this chapter and next chapter, okay? And this ends up being something that you use very often in Algebra 2 as well. And it's used a little bit in geometry, but it's used pretty heavily in Algebra 2. So heads up on that. I was actually just talking with the other math teachers the other day, and we were talking about how our Algebra 2 kids really struggling with factoring a lot, and so we're figuring, okay, well, how can we implement it a little bit more in Algebra 1 to help out with that? So, just heads up, this is something that comes up big in Algebra 2 as well. So just don't think that, hey, if I don't get it now, I'll never see it again. It's not true. You guys will see it again in a couple of years. Okay. So it's important to actually try and learn it. Okay. So let's look at this one. 20y minus 35. What do we think our GCF of this is? 5. 5 goes into both 20 and 35. So our GCF is 5. So we're going to put this 5 where? Let's bring down out. It's outside the parentheses. So now, we don't actually have to write the GCF 5 every time if we don't want. I'm just writing it now, so that way we see, oh, what's happening. Okay. Now, and we don't have to write that this is being divided by 5 every time, but I'm going to write it for now. So what's 20y divided by 5? 4y. What's negative 35 divided by 5? 7. Negative 7. So we have to put minus 7. So 5 times the quantity of 4y minus 7. And if we were to go back through and distribute, we can check. Oh, 5 times 4y, 20y. 5 times negative 7, negative 35. Yes, that is our answer. Okay. Questions on that? Okay. Let's continue on. Okay. So let's look at number
3.
Oh gosh.
Number 25.
Let me change that.
This was nothing like what we just did.
Right.
Yeah, they still have parentheses.
They just have present, they just have exponents.
Oh, that
Bold
hurts.
exponents.
What?
You just did bold exponents.
Kind of.
Okay. So
You can.
let's go on number 3 here. What's our GCF here on number 3?
3.
3. And now-
Actually, it's 4.
Nope. But now, do they have any variables in common too? Before they didn't have any variables in common. They have an x in common. So our GCF is actually going to be 3x. So we're going to put this 3x outside of parentheses here. And now to figure out what goes inside the parentheses is we take each of the terms and divide it by our GCF. So 12x squared divided by 3x is what?
4x squared.
Not 4x squared, but just 4x. Bless you, let's raise down an F goes forget. Because what happens when you have x squared divided by x? What do we do with those exponents when you divide?
You subtract.
Subtract. So what's 2 minus 1?
1.
And another way to think of it, if I'm taking an x away from this 12x squared, if I'm taking an x away from it, we're left with 1. And would 3x times 4x give us 12x squared? Yeah, so that's how you can double check. And we do 3x minus or divided by 3x. 1.
No, 1x is good, it would be 3x squared.
Yep, that's a good way to check. Levi just said, hey, if it was 1x, then if you multiplied it back in again, you end up having 3x squared. Okay? That's the way we can double check our work. So we have 3x times the quantity of 4x plus 1. And we could go back through and distribute this like we just talked about and double check our work. So the only difference between this one and the ones we had before was we also included a variable now. Okay? And we're just going to slowly kind of bring in some more variables to make it a little more natural for us. Okay? Questions on this one? Okay, let's look at number 4. What do we think our GCF is going to be? Once again, we don't have to write GCF up here every time. I'm just getting us in the habit of finding them. Okay, Serenity. Okay, so 3x, and I think there's a little bit more. So they both have 3. They both have at least one x.
3xy.
3xy. Okay, so not only do they have the x now, they also both share a y, don't they? Now, Tara, you had said something about 3x squared, right?
Yeah, I'm so confused.
Okay, so I'm so confused, Mr. Cross. So that first one,
Your hands are cold.
yes. This first one, could we take an x squared out of this first one? Totally. But can we take an x squared out of this one? No. So if we can't take an x squared or divide an x squared out of both, then it's not a GCF both. Just like this first one, could we divide this one by 9? Yeah, but can we divide this one by 9? No, so 9 is not the GCF. Does that make sense? Like actually though?
Yeah.
Okay. So we're going to put this 3xy outside the parenthesis. And then we say, okay, well, it's 9x squared y divided by our GCF. Okay? And we can just go piece by piece. So what's 9 divided by 3?
53x.
Okay, 3. And then what's x squared divided by x? X. And y divided by y, do we have anything left there?
No.
No, just the 1. So it's just 3x. And then we do the same thing here, 15xy squared divided by 3xy.
5y.
So minus 5y. 15 divided by 3 is 5, x divided by x is 1, and y squared divided by y is y.
It's actually sort of fun.
I love factoring. Low key, I get hype over factoring. But
Math teacher.
it's true. But factoring was always one of my favorite things. Okay, so like no cap. So I was going through my notes. Oh, I have a great answer. Okay, I was going through my notes the other day over the weekend. Okay, last Fun Talk Friday. Okay, so I was Hannah and I have standing Friday night date night. Okay, so we just go out and we spend time together on Friday.
For a second, I thought you were talking about this, and I was like, wait, what?
Oh no, and
Where'd you go?
and so so what we did on Friday, like, Hannah had a big test yesterday, and so what we did was we ended up going like just like this coffee shop she was at already, like studying with a friend. I just came and we were like studying together for a while. So like I was working on like my stuff, and she was working on her stuff.
I can imagine
What's she working on?
studying.
So and what?
What was she working on?
So she was studying for an exam over.
Midterm exam?
No, it's like all sorts of nursing stuff, but it's like
Oh, she's being
like
a nurse.
yeah.
That makes sense.
Like
Nurse
gas
and teacher.
changes,
Makes sense.
burn. I don't know, burn's the last chapter. It was a lot. Presley.
Okay, I don't understand. Like when we go to college stuff or whatever, and they like talk about studying all the time. Like I cannot study. I have such a short attention span.
You burned
Like
out
how do
easily?
they do that? Am I gonna fail college?
Okay.
You get
So-
burned out.
That's fair. These are fair questions. So it's something where you have to learn how you study well.
I don't know.
So everyone studies differently, and some people have a hard time with others than others. And so it's learning about how you study what helps you do it. So like Hannah has her routine that would never work for me. To where like she goes through and she like handwrites through all the notes again that she took in class, and like color codes them, and like all this stuff.
I wish
and,
I
like,
could
Yeah,
be a
that's
girl
what I
without
goes-
studying. I just like look at the paper like, hey,
and she just goes super ham on it and intense for a long time, and it takes her hours and hours and hours. And then she loves to discuss it with friends after she goes through that individually, and then like talks about them, asks questions, those kind of stuff. And that process really helps it stick for her.
Does she have a lot of friends?
Okay. Yeah, yes. But this is like a random question. Anyway, that were weird.
I feel like you have a lot of friends. So I was wondering, like, once you guys get married, are you guys just gonna have like a million
We don't
friends?
have a lot of friends, so she's like,
What's that like? I mean, like, I have like a good amount of friends. Like,
Anyway, so, but my method of studying is like way different than hers.
what's
Where like
your-
for like my studying, like I had to just practice and like quiz myself. Where like Hannah, like it's better for her to write down everything first, or like read the information that way, and to go through and do test her, and then like quiz herself afterwards and discuss.
Imagine
For me,
studying on
I'm
it.
best off
Chill out.
just quizzing myself rapid
You know
fire
what I'm confused on?
and just re-practicing finding things. So it's just different for each person, and like there's tons of other ways too. Some people benefit from listening to things. Some people benefit from watching videos. Some are a combination of all these, and so it's just learning how you study well, and then actually making yourself do it. Presley.
you know what's also annoying? Okay, so I do not learn well like what STEAM teaches. And all of my classes are STEAM, but I'm not in STEAM. It's like one of my classes and
I love 18, but I also go to Steam like often. Like a lot.
We're gonna see one every day, baby.
I'm changing my advisory to Roxy advisory next year.
Okay, I have a serious question.
Because
Yes.
heck my advisory.
So why is she still in college and you're not? And you guys are the same age?
She's going to
Oh,
nursing.
She's going into nursing. He's a
What do
teacher.
you mean? I don't know how long
No,
nursing
He's a
no,
teacher.
Okay.
Bruh.
So
Brother.
okay, so nursing can take different amounts of time, but Hannah also took a gap year during her college, so she took a year kind of off. She took like a couple classes, but also went and did like a bunch of mission trips for the course of the year. So yeah, so
Mission
that's
trips
why
for, like,
so it took
churches
her a
and
little bit longer. So
And she's also a year younger than me.
yeah, she's also a year. So she's graduating 2 years after I did from college because of that. So
She
1 year.
graduated this year?
So she's actually done with all of her classes, like her tests and everything like that, in
Dope.
4 weeks. So over our spring break is when she's finishing up, and then she has what they call preceptorship, where she basically goes and like works full time as a nurse.
I feel like this is a good time for you guys to get married. Like right after she finishes school and you guys are both like out of school now.
Dang, you guys are gonna be starting your lives.
It's true. We'll talk.
What if you guys have kids?
Baby castles.
Like
Are
eventually.
you gonna leave us?
Y'all are gonna have baby castles.
Are you gonna leave us?
Yes, to make.
Then your dad jokes will go extreme.
Right?
Oh no.
But just come out with like bright red hair. Probably will, right? Because her hair's red.
I mean, the red hair is a recessive gene though, so who knows?
They're gonna be ginger boys and ladies.
Yeah,
Or
that's
he has,
not-
like,
that's
a
not
black
so
beard.
off topic.
He has a black beard and then
I hope
like
there's
The red hair.
right, he's gonna do reverse you.
It comes out with full beard and teeth.
I saw these pictures of a baby with teeth and it was smiling and it was terrifying.
Okay, let's go back to this. We got way off.
Mr. Casa doesn't like you talking about his children.
Well, no, this just got like way off topic.
His
really
hypothetical
fast.
children, like, okay.
Like,
His
I mean, like, I really hope we're blessed with children. Don't get me wrong. But, yeah, it's just got like really off topic.
Blessed, you can have them at any time.
So,
What did you say?
20x
Blessed, you can have them at any time.
20x squared y cubed plus 40x to the fourth y squared. Ooh, we're getting bigger. Okay, we're getting some more things. We're getting more involved. Okay, what do we think our GCF of this is, Levi?
10xy.
Okay, you're saying
I
10xy.
think it's 20.
No.
Hey, you think it's 20. Okay, why do you say 20, Victoria?
Because 20 times 2 is 40.
Okay, so 20 goes into both. So does 10 go into both?
Yes, but
Yes.
it's smaller.
But it's smaller, so 20 does go
Like
into
10
both.
and 20 are like basically the same number, just like
Bruh.
not really, but like.
Okay.
Brother,
Yeah.
Okay.
Chill, bro.
Okay.
Chill.
So I would agree that it'd be better for us to pick 20 as our GCF. Now, I want to walk through though and say what would happen if we went with Levi's suggestion first, and how we could go back through and finish off. Okay. But Nectaria is right that it would be a 20 instead of 10. So let's. Don't write this part. Don't write this part. I want you guys to see this. So we call this 20xy or 10xy, and we divided this by 10xy. We did this with 2xy squared plus 4x to the third y. Now, do we notice inside this parenthesis, is there still more we can take out of the 2 and 4?
Yeah, so that's.
Yeah, what can we still take out? A 2. So you have to factor out another 2, and what happens is, let's forget. What happens is as you factor out another 2, you have to multiply the 2 you factor out with what's already out here. You have to multiply the 2 times a 10 and get 20. Multiply the 2 times a 10 and get 20, and then we factored out or divided out another 2. Okay. Now, one thing I don't want you to write this down though, because we actually have more we can do than that even. Okay. So I agree 20 would be the number we want. But can we do more than just x and y? What do they have in common? They don't have
points. 20.
x squared. And how many y's do they have in common? 2, so y squared. So we can actually factor out 20x squared y squared. Because they both have at least an x squared there. And they both have at least a y squared there. So we're limited by the least amount that one of them has, but the least amount that either of them have is a squared. So now as we have our GCF of 20 x squared y squared, and I divide both these terms by our GCF, what's 20 divided by 20? 1. What's x squared divided by x squared? 1. And what's y to the third divided by y squared?
Oh, y 1.
Just y. Or y to the first. So we're left with the first part just becomes y.
Yes.
Plus 40x to the fourth y squared divided by 20x squared y squared. What's that become?
20x squared.
20.
2x to the
2
second.
Why is it
x squared.
20 that?
Becomes 2x squared. And now what we could go through to do to check that we got it right, that we factored it correctly, is what we did last chapter, is distribute. And go through and do, 20x squared y squared times y, that's 20x squared y cubed. 20x squared y squared times 2x squared, that's 40x to the fourth y squared. And we look inside our parentheses, And do these have anything more in common inside of parentheses? No, they don't. None of the numbers are in common. None of the variables are in common. So we're completely done. On this number 6 here, or excuse me, questions on number 5. Presley, I feel like you have a question, but you aren't asking it.
Ask the question. Ask the question. Ask
Just
the
confused over the
question.
entire thing.
Are you confuzzled?
I understand it. It just takes me a long time to process.
Processing.
Just making sure.
50%.
So let's look at number 6 here. Now we have 3 terms. Hey guys, now we have 3 terms here, okay? So instead of just looking at what goes into 2 of them, we get to look into what's the GCF of all 3 things. So you have just more things to compare. So you have more things to compare and worry about. So what is the GCF of all 3 of these terms?
5.
Okay, 5A.
5AB.
Okay, 5AB, do they all have a B?
No. Wait, no.
No. Darn it, the first and the third one have a B.
Sorry, I can't see.
The middle one doesn't, darn it, so we can't, okay? And even though the middle one has a squared, the most they all share is the 1a, so the a to the first. But the GCF would be 5a. So you write the 5a outside the parentheses. And I'm going to start challenging us by actually not dividing each of these.
What's
What's 15ab divided by 5a?
3?
3b. So if we divide the 5a out of this, we're left with 3b. If we factor 5a out, we're left with 3b.
And then it's
Yes.
5.
Yours is a different order, like a lot.
Yours is? Perfect. Okay, I need to change this. Okay, thank you.
Do we? What?
No, you guys are having it right. I needed to change it on my on this, and I forgot to change on this, but I changed on that which I meant to. Okay, so yours says 25a squared plus 15ab, or excuse me, plus 10ab squared.
Why you do that?
Because that's how it's supposed to be. I messed up
Why
last
you
year.
do that, dog?
Plus 10ab squared plus 15ab. That's how yours is written, right?
Yes.
Okay, awesome. So that doesn't change what the GCF is, though. This GCF is still the same. It's still 5a. It doesn't matter the order we have them in. Our GCF is still the same. So now let's put this 5a outside, okay? Let's try this again. So 25a squared, factor out the 5a,
It's 5 squared.
is 5a. That's what you were saying a minute ago, right? So you had it right. I was asking the wrong question.
It's across your phone and everything.
I know. Man, okay? What's 10ab squared, and if we factor out the 5a?
2ab squared.
Not 2ab squared, but 2b
B squared.
squared. So we factor out the 5 and get 2. Factor out the a, we don't have any more a's left. So we just have b squared. And then 15ab, factor out the 5a is
Plus 5b.
plus 3b. And we can double check our work and say, hey, 5a times 5a, 25a squared. 5a times 2b squared, 10ab squared. 5a times 3b, 15ab. And one more just clarifying question. Before we box our answer, is there anything we can take out more or anything we have in common inside the parentheses? Nope. Okay, we're done. And we do have it in standard form, don't we?
Yo.
Okay. So that's what I changed from last year to this year. This was last year's, and I forgot to change it on the presentation. I changed it here as no packets because this is not in standard form. So I changed it to be in standard form.
Good job.
Actually, I need to change this to be in standard form too.
I have a question, but not about this.
Okay.
What's your question?
Is it about math at all?
Yeah.
Okay, can you hold on to the question for about maybe
That's why
5
you
minutes?
lie and say
Yeah.
it
Dylan, no. Lying's not good.
It is in certain cases.
No. Okay.
Will
You
you
guys,
lie?
yes. I'm
Who has
not.
I'm literally the best liar in the world.
Everybody lies some point.
Yeah. I'm not proud of it.
What was it
Dodge
about?
your question and knock it off topic, and we still did it anyway.
I know.
Got him.
3x cubed
You're
plus
welcome.
6x squared minus 9x. 3x is their GCF.
Good job.
Okay?
Oh my goodness.
I'm going to challenge this one step further, and I'm not going to write the GCF down. You can if you want, but we don't have to.
Please write it down.
Okay? You can write it down.
E, C, F, G, H,
I'm doing it because you know what?
Okay? I do it because you know what
squared.
helps me.
Jeez, you're supposed to say me.
So,
Haven't I taught you
What?
anything?
are we left with in the parentheses? I want you guys to write down what we're left with in the parentheses. When you have it, or have questions, raise your hand. When you have it, or have questions, raise your hand.
Mr. Gossel. Just kidding.
Hey, Serenity, check me, please.
Yeah, you got it right.
Let's go.
Oh, you doing a health check?
Yeah.
Why did you make that noise?
That's right. Okay, I'm done.
I didn't enjoy that noise.
Ah!
The X right there. Because if you.
I got you.
I can't read.
Hey, yo, Serenity Myers, can I have?
Good job.
Yo, can I have your hand?
Yeah, you got it wrong.
Yes!
You're supposed to do it. And there's an X.
There is an X right there. Look, there's an X.
You're not supposed to have an X in. The X is right there.
Hey, Matthew, you should grab your hair and get dreadlocks. Cornrows.
Yeah, if you put
Red hair with cornrows? I feel like
What?
that's
Oh,
bad.
for who?
Matthew, who in your family is ready?
God's here, bro. You just running around with cornrows.
Him.
No one in like I feel like one of my brothers and sisters.
Yeah.
Oh, you have a sister?
My mom, brother has red hair.
Your uncle.
And then
I wonder what your beard
My
is.
uncle, I don't have one.
dad's green hair.
Oh, yeah, I do. I'm
Black
in
beard.
Tucson.
So,
always seem to get out.
yes.
No, he skydives and
Presley, do you want to
dives.
write what goes in here? Okay, Serenity, you want to
I
write
do.
what goes in here?
Yeah,
Okay,
sure.
go.
I know it goes in there.
You wanted it.
What?
I wanted to.
I asked Serenity the same time you said it. Sorry, I can't read your mind.
It's okay, you know what? That's what I was expecting out of you.
Yeah, that's fair.
Good job.
Very good.
I'm sort of happy you can't read my mind. My mind wanders.
Yeah,
That's the one
Nice.
superpower I want
Okay.
to have.
I
So
don't
now,
want you to
hey,
have
guys,
it. No,
As we
you
look
don't.
at the GCF of this last one, number 8.
That would be too awesome.
Here's the thing. We want our first term to end up being positive.
You'd be
We
able to
want our
guess it.
first term to end up being positive. So it should be factor out. Instead of a positive 2, we should factor out a
-2.
-2.
Wait, what?
Wait, what?
Okay?
I don't like
And
that.
the reason why is we want our term to end up positive. Okay? We want the first term to end up positive. Okay? We look at the first term, we say we want that to be positive. So if we factor out a -2, what is -2a squared divided by -2?
A squared.
It's positive a squared, which is what we wanted. Minus 4a, because 8a divided by -2 is -4a,
Plus 2.
Plus
plus 2.
8.
I love
So
that.
notice how we changed our signs though?
Factor in
Okay.
This is so much easier.
Shit, what you been doing?
I think Mr. Collins should get cornrows.
What?
I want a mullet. I
Cornrows.
keep telling Hannah I'm gonna grow out a mullet for the wedding.
Dude, do it!
No.
I'm
So
growing out
nice.
mullet this summer.
You make a killer mullet.
I'm
No,
growing
do not get a mullet.
mathematics, get a
No,
mullet.
that would look so
Mullet.
good.
Matt's get a mullet.
Yes, man.
Matthew's the one person I think
that
would
had
look good.
long red
Whoa,
hair.
whoa, I'm getting one.
Thickest mullet. I mean, it went all the way down to here.
Who does?
That's lit.
Who does?
That's dope.
Oh, the one.
Okay, so
That is
Yeah,
what?
we made it to the finals.
Oh, okay, that's what I heard.
You know what I was gonna say? How come when I go to bed at 11, I'm way more tired than when I go to bed at 2:30?
I know, right?
Dude,
I'm
I was
exhausted
okay.
right now.
I
go
was
to bed at
straight up
11.
on something last night.
And
I
like
went to
all
bed
last
at
week
9:30.
and yesterday, or the night before last night,
Eugene,
I went to
give me
bed
my-
at
put
like
it on your
2:30,
table.
2:45.
Move your hot.
And sometimes it just catches up with you though too.
Like I'm exhausted right
What
now.
time
I
do you go
can't
to
keep my
sleep?
eyes
Did I go to
open.
sleep last night? Yeah. Like 11. A little later.
Kendra, you're
Later than
actually
I wanted.
Mr.
Okay,
Thompson,
but
that's what's
I don't feel like
amazing.
it in my brain.
Dude, I was on something last night. I went to bed at 9:30.
Maybe you were off something.
Hey guys, we're gonna do the same thing we did on our notes.
You didn't give us pictures.
Hey,
Tar.
guys, you don't have to do the back by the way.
Oh,
thank
really?
you, you're so
I didn't
clever.
notice. So clever.
You really didn't have to make us